All right, so this first section is 13.1. It's called right triangle trig. Okay, whenever I hear right triangle trigonometry, the first things that I always think about in this order are Pythagorean Theorem, special right triangles, and Cosecant. These are all things that you should have learned in the past, but if not, here's kind of a catch up for you, if you will. All right, so the reason why the first thing I think of is Pythagorean Theorem whenever I see a right triangle is because that's the easiest one to use to find a missing piece. For example, if I'm missing either side A, side B, or side C, as long as I'm just missing one side, I can use the Pythagorean theorem in order to find the other side, the missing side. All right. So the Pythagorean theorem, for those of you that don't remember, is simply c squared is equal to a squared plus b squared. Now, I particularly like, instead of, as many of you might have learned, a squared plus b squared equals c squared, I like to think of the Pythagorean theorem the way that I just wrote it there, because I can also determine whether triangles are acute or obtuse based on this. For example, if c squared was less than a squared plus b squared, it's not a right triangle, it's an acute triangle. And if c squared is greater than a squared plus b squared, it's not a right triangle, it's an obtuse triangle. All right? The second thing you should know is these rules for 30, 60, 90, and 45, 45, 90 right triangles. All right? Now, the way that I remember it is everything is based off of knowing the shortest side in this 30, 60, 90. The shortest side is always directly across from the 30-degree angle, and I name this side by calling it shorty. Now, as long as you know shorty, you can find the other two by following this pattern or this algorithm that comes from it. For example, if shorty is x, I know that the hypotenuse is going to be 2 times x. If shorty is x, I know that the long side across from the 60 is going to be x times the square root of 3. And literally that's it. So for example, if shorty is 5, hypotenuse is 10, long side is 5 radical 3. Whether you're going from shorty to the other sides or reversing it, going from long to shorty, the key again is always to find shorty. So as a quick review, remember to go from long to shorty, we would divide by the square root of 3. In order to go from hypotenuse to shorty, we would divide by 2. Now 45, 45, 90 is a special triangle also in the sense that it is isosceles, which means because of those 45-degree angles, I know that both those sides have to be congruent as well. All right, because of that, that's kind of my base, if you will. All right, I know that the key to doing 45, 45, 90 is to know a leg. A leg is one of these two sides. If this leg is x, the other leg has to be the same thing. Why? It's isosceles. All right, and then through the use of the Pythagorean theorem, we could figure out that this hypotenuse here is going to be x times the square root of 2. One additional thing for these specials, 30, 60, 90, 45, 45, 90. The way that I keep them straight in my head, remembering which one to use square root of 2 and which one to use the square root of 3 for, is I think about the sides. I know, for example, in 45, 45, 90, there are 2 unique side measurements. That's what reminds me to use the square root of 2. I know for 30, 60, 90, there's 3 unique side measurements. That's what reminds me to use the square root of 3. The third thing for right triangles is we need to keep in mind SOHCAHTOA. SOHCAHTOA is our acronym to help us remember the 3 basic trigonometric functions of sine, cosine, and tangent. All right? If I have a triangle, right triangle here, and I identify one of the angles as theta. Theta is a Greek letter used to represent an angle. All right? I know in relation to theta, the side directly across from it, I can call my opposite side. I know the side directly across from the right angle is known as the hypotenuse. And I know this other side right here that's right next to theta is known as the adjacent side. So I wrote in there the abbreviation. Now, there are 6 basic trigonometric ratios. 3 that you should know, 3 that you may not know, but they're pretty simple in the case of they are reciprocals of what we are given. All right, so in order to find the sine of theta, what SOH abbreviation tells me is that its ratio is going to be the side opposite over the hypotenuse. The cosine of theta, CAH, tells me its ratio is going to be the side adjacent divided by the hypotenuse. And the tangent of theta, TOA, is representing the side opposite over the side adjacent. So these give us our basics, all right? These are what we use eventually to find missing sides and or missing angles in any right triangle, okay? But these three also have what are called reciprocals, okay? Now remember, reciprocal just means you're going to take the ratio or the fraction and flip it over, all right? So let's go through. This one is called cosecant. The reciprocal of cosine is called secant, and the reciprocal of tangent is called cotangent. Now, as we saw before, these all have abbreviations as well. I know that cosecant, CSC, of theta would simply be take the sine and flip its ratio over. So it's hypotenuse over opposite. This is also known as 1 over the sine of theta. All right, secant is abbreviated SEC. So the secant of theta would be take the cosine's reciprocal, hypotenuse over adjacent. Or we could also look at this as 1 over the cosine of theta. And then cotangent is COT of theta, and that's adjacent over opposite, the reciprocal of tangent, or 1 over the tangent of theta. Okay? So in this problem right here, they give us a picture of a triangle, and they give us the 3 side measurements in that triangle. They want us to find the 6 trigonometric ratios, and they tell me what angle to use as my reference angle. In this case, G. So the first thing that I want to do is try to figure out what are my sine, cosine, and tangent. And I'm making sure to remember SOHCAHTOA to help me with this. I know that the sine of G is opposite over hypotenuse. I can reduce that fraction, so I go ahead and do so. All right, I know, let's see, 8 goes into both of those, so that would be 3/5. I know that the cosine of G, not theta, sorry. The cosine of G is going to be adjacent over hypotenuse, which would be 32 out of 40. And again, I can simplify that to 4/5. The tangent of G is going to be opposite, 24, over adjacent, 32. And if I simplify that, I get 3/4. So I found the 3 basics. Now I need to figure out the other 3 reciprocal trigonometric functions. Now, an easy trick to help me remember what goes with what. I think tangent and cotangent, it's kind of clear that they go together. All right, the other one, sine and cosine, and secant and cosecant, here's what I remember. C goes with S. All right, so in other words, sine has to match up with cosecant of G. And to find the cosecant, I take the sine ratio and flip it over. There we go. That's the reciprocal. C and S. So cosine has to go with secant of G. Take its ratio and find its reciprocal, 5/4. And then the cotangent of G would be the reciprocal of the tangent, or 4/3. All right? A second type of problem that we might get is, what if they give me a situation like this? This is very common on standardized tests. All right, what I want to do with this problem is I want to go ahead and sketch for myself a right triangle. And one of the angles in that right triangle, not the right angle, I want to call angle A. Now they tell me that the tangent of A, I know tangent means opposite over adjacent, opposite over adjacent. So I'm going to fill this in as opposite and adjacent. I now know 2 of the 3 sides in a right triangle. I can find the third side by using the Pythagorean theorem. So in this case, my hypotenuse is going to be the square root of 3 squared plus 5 squared, which would be the square root of 34. All right? Now I'm ready to find the cosecant. I know that the cosecant is the reciprocal of sine. I know that sine is opposite over hypotenuse. Therefore, this has to be hypotenuse over opposite. The hypotenuse is the square root of 34. The side opposite of A is 5. And there's the cosecant of A, square root of 34 over 5. Okay? The second thing in this lesson is how do I find sides and angles of right triangles? So I've typed in here my process that I use. Step 1, I set up the trig ratio using SOHCAHTOA. I'm not going to worry about using the reciprocal functions. I'm just going to use SOHCAHTOA. All right? I set up the trig. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If a side is missing, that means I'm either missing the top of the fraction or the bottom of the fraction. If I'm missing the top, multiply by trig. If I'm missing the bottom, divide by trig in order to find the missing measurement. The third scenario would be if I'm missing an angle. Well, and if I'm missing an angle, I'm going to use what's called inverse trig in order to figure this out. Now I'm going to talk. We got some announcements going on. I'm going to talk over it. Okay? So hopefully you can still hear me here. In this first scenario right here, I have the 60-degree angle. I know that x is opposite, and I know that 12 is the hypotenuse. So I'm thinking SOHCAHTOA, and I have opposite and hypotenuse. That's telling me to use the sine function. So the sine of 60 is equal to opposite over hypotenuse. Notice all that I did there was write the trig ratio. Now I analyze it. I'm missing the top of the fraction. To solve this, I'm going to multiply by trig. So I'm literally going to take 12 times the sine of 60. Now, this calculator is going to do it a little bit different than maybe some of yours will. Most of yours will. But on this one, I have to go 12 times 60 sine and then hit equals. Typically with sides, we round to the nearest tenth. So I'm going to say x is equal to, I think it was 10.4, wasn't it? Yeah. X is approximately equal to 10.4. Okay? Now, a second thing that they could ask you to do would be solve the triangle. Solving the triangle means you have to find all 3 missing angles and all 3 missing sides. All right, so if I'm going to solve this triangle, the first thing I'm going to do is organize my thinking. I know I need to find zy, I need to find zx, and I need to find xy. Now, zx I already know, so I'm going to fill that in. I need to find angle y, I need to find angle z, and I need to find angle x. Well, angle x is 18 degrees. Angle z is 90 degrees. Now, we all know that in the triangle, there's 180 degrees. So in order for me to find angle y, I can go ahead and do that real quick here by simply taking 180 and subtract 108 from that. So if I have 180 minus 108, I get that angle y is 72 degrees. All right, let's find zy. Now again, I'm only going to use what I'm given. All right, I want to do that as much as possible. So to find zy, I know that this zy is opposite of the angle 18 that I'm given. I'm also given the side that's adjacent. So to find zy, I know that I'm going to take the tangent of 18, opposite over adjacent, is equal to zy over 11, which is the side adjacent. All right, we're going to come back there and solve that in just a minute. But let's also find the hypotenuse. So I'm going to find the hypotenuse, which is yx or xy. I'm given the side adjacent, so that tells me to find xy, I'm going to take the cosine of 18 degrees is equal to adjacent over hypotenuse. Hypotenuse again was xy. Now, in the first one, I'm missing, or I don't know, the numerator, the top of the fraction. So I'm going to multiply by trig, 11 times the tangent of 18, and I find that to be 3.6. To find xy, I'm missing the bottom of the fraction. So in this case, I divide by trig, 11 divided by the cosine of 18, and I get 11.6. And that's how you solve a triangle. So let's try another one here. So on this triangle, let's see what they give me here. They give me all the sides. So I'm going to say AB is 17. I know that BC is 9. And I know that AC is 14.4. All right, from those sides, I know I need to find angle A, I need to find angle B, and I need to find angle C. Well, I already know that angle C is 90 degrees. To find angle A, I can use any trig that I want to. I'm going to go ahead and use sine. So the sine of angle A is equal to 9 over 17. Now, because I'm missing an angle, I use inverse trig in order to calculate it. All right? So here's how you do inverse trig. You're going to take on your calculator, you're probably going to go second sine and then type in 9 divided by 17. I have to go 9 divided by 17, get that answer, and then hit this shift button and hit the inverse sine button. Now, I'm going to round this to the nearest tenth, but it would round to 32.0. So angle A is 32.0 degrees. And because I'm rounding to the nearest tenth, I'm going to put that tenth in there. All right, angle B, let's see. To do angle B, how about we do, let's do sine again. So I have the sine of angle B is equal to 14.4 over 17. Again, go to my handy dandy calculator. I'm going to take 14.4 divided by 17. I get that answer. And then I'm going to take the inverse sine of that. I use sine, yeah. And I get 57.9. 57.9 degrees. All right? And those angles, if you notice, they almost add up to 180, but not quite. We're a tenth off there. That's okay. That's okay. If I were to round these to the nearest whole number, I get 32 and 58. There's my 90 degrees. This is just a more accurate representation of that angle. So the last thing we're going to talk about is what's called angles of elevation and angles of depression. All right, pardon my drawings here, but let's say here I am, and wow, that's a bad drawing. All right, and I look straight out, okay? And up here we have a little balloon, let's say. All right, that's really bad. If I were in the balloon and I look straight out, that would be my line of sight or my vision, okay? An angle of elevation means if you look straight out and then you look up, this is your elevation. All right? If you're in the balloon and you're looking down at the person, I look straight out and then I look down, this is my angle of depression. Now, what most of you should recognize, because my lines of sight were parallel lines, I know that the angle of depression from the balloon and the angle of elevation for myself should be congruent angles. All right, two parallel lines cut by a transversal, alternate interior angles are congruent. All right, this tool is helpful sometimes. So let's look at a scenario here. A ski run has an angle of elevation of 15.7 degrees and a vertical drop of 1,800 feet. Estimate the length of the run. All right, so here's what I know. I'm going on a ski run. This is my run right here. I'm going down a hill. They tell me on this that there is a vertical drop of 1,800 feet. They say it has an angle of elevation of 15.7 degrees, which means this angle down on the bottom is 15.7. Remember, elevation means look out, then look up. Okay? All right, so from this, I can use trig to figure out the length of the run. From 15.7, that's my reference. Opposite is 1,800. The run here would be my hypotenuse. All right? Opposite hypotenuse, that's the sine function. So the sine of 15.7 degrees is equal to opposite over hypotenuse. I'm just going to call that R. All right, now I go into the phase of how do I solve it? I'm missing the bottom, divide by trig. So let's see here. I'm going to take 1,800 and divide it by the sine of 15.7. And remember, again, I have to kind of type this in backwards. Sine of 15.7, hit equals, and I get it's about 6,651. The run, 6,651 point, let's round to the nearest tenth, 0.9, and that would be feet. All right, hope this helps you guys. Good luck. Let me know if you have any questions.